Last time when we left off, we had just used Solver to find the optimal solution, which is producing 560 basic computers and 1200 XP computers. So what we're going to do now is look at the sensitivity report. In order to get the sensitivity report, we're going to click this sensitivity setting under the report function, and then go ahead and click OK. And it puts a new tab in front of the old one, so go ahead and click on that new tab and we can see the sensitivity report for our model. Now the important question for you to know the answer to is, what is this model actually telling you? Well, it is telling you that you are going to produce 560 basic computers and 1200 XP computers. That's your final value. It's also telling you your objective coefficient, that your unit margin is $80 for each basic computer and $129 for each XP computer. So that means that the company actually makes $80 on the basics after they pay for the costs, and they make $129 on the XP. What is most interesting to you in this problem is the allowable increase and allowable decrease on the unit. So what this is telling you is that this coefficient, which is the net margin, can increase by $27.50 before the model might change. Now you don't know how the model would change if you went to $28, more than 80, but you do know that it could change. You would have to change you would have to change the net margin to be $108 and rerun it to see what that would do to the solution. Alright, it also tells you that this could decrease, this $80 could decrease by $80, which would mean that it could go all the way to 0 and it wouldn't change your ideal solution. Does that make sense? Well, let's look back at our model. And indeed, we are already producing all of the XP computers that the market can handle. So our maximum sales here is 1200, and we're already producing 1200. So that means that any of these that we can produce with the remaining hours are better than letting that profit go and not realizing it at all. The shadow price down here is, oh, I'm sorry, I haven't explained the number to produce on XP. So XP, you could increase the unit margin to infinity. That's what this 1e plus 30 is telling you. It can go to infinity and it's not going to change your model. Again, that does make sense because you're already producing the maximum number of these you can sell. It can decrease by up to $33 before the model would change. All right, and again, we don't know how the model would change, and that's why we're going to do this again with Solver Table in just a minute, because Solver Table gives you better information than the sensitivity analysis. All right, so let's talk about the shadow price right here. The shadow price has to do with the constraints. So this first constraint here is the labor availability for assembling hours used. We have up to 10,000 hours used for assembling. And again, if we look at our model, we can see that we have used all 10,000 of these hours. Okay, so we hit a hard limit on that constraint, and it's what is keeping us from being able to produce the other 40 computers that we could produce to maximize sales. So this shadow price is telling us that if we could add, for every 1 hour we could add to this final value here, this 10,000, we would increase our revenue by $16. And again, the allowable increase and decrease are similar functions. So the allowable increase here means that up to 1,200 hours, we would increase our net profit by $16 for each hour we could add. And it could go all the way to 0, and we would be costing ourselves $16 every time we took away an hour. There is no shadow price for the 2960. That's because you have up to 3,000 available, which you can see right there, and you're only using 2,900 260 of those hours. This means that you're already not using all the hours you can add, so it doesn't add anything to your bottom line if you add more hours here. It will not increase your profit. You still couldn't produce more machines because this one is the one that this labor hours for assembling is the one that's already at a hard limit. Again, your allowable decreases here. You could allowable increase is if you didn't change the labor hours for assembly on the line above, you could increase this to infinity and it wouldn't add anything to your profit. Now, if you decrease the number of hours by more than 40, so that means you had 3,000 available, you decrease it by more than 40, which would be 2,960, that would then start to change your solution. And again, we don't know how it would change the solution. You would have to rerun the solver in order to find that out. So let's go look at a program that would actually give us a little bit more information without having to constantly rerun Solver, and that is Solver Table. It is an add-on. You have access to it through your student resources with Cengage. If you are near the Southeastern University campus, there are several computers in the library that have that software loaded on them. If you are not able to load it onto your computer, you do have to have a Windows machine in order to get the software to run. It does not, most of the software, the specialized software for this class, does not run on a Mac unless you are able to, I think it's run Parallels and have Windows running on your Mac. All right, so let's go ahead and look at how to install the Solver Table. It is an add-in, so it's a similar process to what we did with the Solver. We're going to go to Options. It's File and then Options. And then we're going to go to the Add-ins. And we're going to go to Manage Excel Add-ins down here at the bottom and press Go. And we're going to add in Solver Table. Now, I'm going to go ahead and browse for Solver Table because that's what you're going to have to do. And you will have to know where on your hard drive you have saved it and then go tell your PC to find it there. So I'm going to go to where I have that saved. And here is my Solver Table. Go ahead and push OK. Yes, you shouldn't have that because you won't have it in already. I took it out so that I could show you how to install it. It will come in a zip file and you will have to extract it before Excel will see it. So when you download it from Cengage, it will be in a zip file. You've got to extract the contents of that file before Excel can see it. All right. So once you've gotten to this point, go ahead and push OK. And give Excel a second. Now you see that this new ribbon option has popped up, so you can click on Solver Table and we can click on Run Solver Table to get the window up. First of all, it's going to give you a message that tells you have to have an active solver running in order to run the Solver Table. So go ahead and click Yes on that message. The first one we're going to do is a one-way data table. So go ahead and make sure one-way table is selected and press OK. And what we want to find out is how the selling price of the XP unit affects the solution. So we're going to select the selling price, which is cell C11. So you can click on that cell. And we will add a descriptive for it. So selling price XP. Okay. And your minimum value here is going to be 350 and your maximum value is going to be 550, and you want it to vary in increments of 25. Okay. And then your output cells are going to be B16, C16, and D25. So the reason we want those output cells is we want to see how varying that one input, which is the selling price, will affect our decision variables, which is B16 and C16, and our objective cell, which is the total profit. Okay, so once you have all of that entered, go ahead and press OK. And solver table added another sheet, so your model is still there on sheet 2, and this new solver table is on sheet 3. Okay. So let's discuss how to interpret this thing. First of all, in column A, you have the selling price of the XP model. So again, we started at 350 when we went all the way to 550. And then the number to produce in column B, it tells you how many of the standard models you are going to, or the basic models, I'm sorry, how many of the basic models you are going to produce if the selling price of the XP was $350. Number to produce 2, which is in column C, tells you how many of the XP models you're going to produce if the selling price of the XP is $350. And column D gives you the total revenue. All right. So let's talk about some management decisions that we would make on this. Let's talk about some key data to pay attention to. First of all, if the selling price of the XPs is $400 or less, then you are going to recommend to your manager to produce all of the basic computers that the market will handle. In other words, all that you can sell. And then you would use anything left, any production capacity left to produce XP computers. That changes when we get to $425 as the selling price for the XP, which you can see in A8 here. So at that point, you go back to 560 basic units produced, and you produce all of the XPs that the market will bear. So all of the XPs that you can sell. And of course, you can see in total profit that the higher your selling price of the XPs, the more profit you are going to earn, which intuitively makes sense. Next, what we're going to look at is a two-way solver table. And so you have to go back to the sheet that your model is on and make sure you're still on the solver table. Click Run Solver Table again and click Yes again. We have an active model on this sheet. And click Two-way as the type of table and then click OK. So your input cell here is going to be D21, and D21 is the number of labor hours that are available for assembling. Click input cell and then select D21. Okay, and our descriptive here is assembling hours. Your minimum value here is 8,000. Your maximum value is 12,000, and your increment is 500. Okay. Your output for cell 2 is the number of hours available for testing, labor hours available for testing. Okay, so we'll label that testing hours. And our minimum value here is 2,000. Our maximum value here is 5,000. We're going to vary it in increments of 500. Our output cells are going to be the same as in the last model. We want to see how that affects our decision variables and how it affects our objective cell. Okay, then go ahead and press OK. And here we have a table that shows how these two interact. So if you have 8,000 assembling hours and 2,000 testing hours, you are going to produce 600 of the basic computers. Okay? And I'm sorry, yeah, 600 of the basic computers. You would produce 700 of the XP computers in that circumstance. There's all kinds of information here, and I will have to do another video to show you how to interpret all of this. So more to come, and hope you have a good evening.